Hello, everyone. Welcome back to another week of
Hello,
content.
folks, everybody. How are you doing today?
Good. It's been a long week, but
Oh,
I was excited because we stopped to a certain point that is a point that is, you know, very close to me, and I was looking forward to this chat today, Teo.
really? Well, it's been a long day, and it's been. I love this chat actually. So they are actually very insightful if you're following along and so on and so forth. People, I like the questions. I like the interactions. So please keep asking them. Okay, we will reply. It's pretty
Don't
cool.
stop asking. So last week we stopped with authentication authorization at the point where we were moving to zero trust.
Zero trust networks. Okay, so I
Where
have
do we
been.
start?
Okay, let me tell you this thing because at some point I set myself into learning how all of these would work and how you set up a zero trust system. Okay, um, and it was quite a fascinating drive. Okay, in learning all the bits and pieces. So the first problem, okay, is
First of all, when you started, that's the more important.
I done long, like it was a long time ago, and then every single time I need to go deeper and deeper. And the last depth into the problem, I think I did, I don't know, not so long ago. Okay, um, because actually it was very hard at that point in time. I needed to solve some, some very deep nested protocol thingies, and that was really tough. So, um, and I need to learn. So I actually, well, learning means building. So yes.
So zero trust comes. I mean, my first mesh I designed it in 2013. So I was probably a precursor to Envoy and the modern mesh and zero trust. But it starts with a principle, right? To never trust, always verify, and
Yeah.
start with distrusting any peer that is in the network. That's the kind of like concept. Um, and it's getting super interesting when we think about distributed systems and non-homogeneous microservices, right? So imagine a system where we have different actors that are built by different teams, different entities, and they need to live in the same mesh network, right?
Yes.
Um, so until then, we had, and that's something that we touched upon last week, session-based communication, right?
Yeah.
Everything was
Oh
a
gosh.
session, right? And now we basically move into a space of continuous verification where you continuously ask,
Yes.
can I do this? Can I do this? Can I
Yes.
do this? Am I
Okay. Let
authorized?
me let me make an example.
Mhm.
Okay. So, um, if you have two peers, okay, in a network, two servers, okay, and you send some, it send you some data or some metadata about self, okay, declaring, I don't know, I am this service, I'm doing this, I'm doing that, okay. You should not trust this, okay. The system you're building should not be trusting this thing, okay. You might have some anchoring trusts, okay, but that which you have to, okay, but that's the limit, okay. That's the top limit of what you need to do. And for example, if you need to say, okay, I have this information, okay, about myself, and then you can go and verify that information with somebody, with another peer in the network, with another service. Go verify that peer in the network, okay. Might not be immediate, might be a batch process, might be, you can make those systems in a way that are performant, but it's actually important that um, if you don't do these kind of things, then you set up yourself with for a load of pain in the future, load of pain.
Yeah, because I mean, there are different ways, right, in or implementation of zero trust. You have proxy based and service mesh, right?
Yeah.
That's basically the two ways. Just to describe the service, so proxy based, it means that you kind of like have a single entry point that does identity termination and authorization. And then this one is propagated through the services. So you basically kind of like carry along some sort of like policy, or you carry along some sort of like, session. The other one is the service mesh, which basically distributes that to the single sidecar. So every single node has its own control on accepting or denying, request. Right.
I'm laughing, Luca. Then I have a story here, and then we can chat about the story. I have a story.
Yeah, no, tell me the story. Now I'm
Okay.
curious.
Okay. A long time ago, okay, I was doing there was a performance issue, okay, on one of my consulting customers, and long time ago. And this the problem was related to Istio.
Mhm.
And no, Istio is probably the most popular mesh network. Okay,
It
as
was.
it was. Okay, it was the most popular mesh network. Okay, and then it handles HTTP traffic, it handles TCP, it handles HTTP2, it handles gRPC. Okay, and because of a bad alignment of stars, okay, it was not respecting, okay, the stream back pressure or flow control on gRPC streams between peers. So if the sending peer was sending too much data, it will out of memory the envoy thing. Actually, it was not Istio, it was envoy. Was
That's actually strange, because Envoy is
but
extremely.
the bug was not in envoy. Okay, the bug was in the gRPC JS library that was misinterpreted. It was working with back pressure if it was between peers, if we were talking with Java and whatever. But if we were talking with Envoy, it was sending data. It wanted data in a very strict way according to the spec that was not exactly the same.
Oh, probably for the headers, right? Because in a mesh,
Yes.
the sidecar does a lot of header rewrite, right?
Yes,
To kind of like.
it was a thing, and then it was exploding. Okay, and then fixing that was fun. Okay, and well, the problem is debugging it is fun. Okay, like depending on your kind of fun, but it's my kind of fun. But it's for a lot of people is the stuff that you can debug for months and months and months with no end to it, because it's so hard deep. I ended up reading huge amount of envoy code to figure this thing out. Okay, because it was impossible to know. Like it was very.
Yeah, I mean, when you look at, for example, zero trust and a service mesh, clearly, I mean, just to explain how it works. So in a proxy base, you have in Kubernetes, for example, you have your ingress that is a gateway, and it does authentication termination, and then you have all these services that they kind of like trust the work of the ingress. So how you set it up is to basically mask all the services behind the ingress, so they're not reachable from the outside. You reset that all the connection is to go through the global DNS, and they cannot do pod to pod. So you could do it in a million of ways. But in a mesh, you allow for point-to-point communication, right? That's basically the goal of a mesh. And you have your pod, which has a sidecar. The sidecar can be anything. Most of the time, we're talking about Envoy. And then this is called the data plane, and you have a control plane that controls all the policies and distribute policies that locally are evaluated by the data plane, right, by the sidecar. A small caveat there. Why would you use something like that? Is because somebody, some entity unknown, came with the idea that in an enterprise, in a large distributed system, or in a large microservices system, you cannot define ahead of time the interactions between services, because that's the principle of microservices, right? Is the fact that you don't care who's calling you, right? You know that somebody can call you and get some sort of data. But with the service mesh, you control authorization at that level, right? It's not about authentication, it's about authorization.
It's not just about that. It also provide automated open telemetry information. So it's actually very useful for that, because it sits at that boundary. It can, if you just propagate the correct headers on your end, you can do open telemetry reporting very easily, and it automatically fill it up correctly. So it's actually not that bad. It's actually very powerful using this in this way.
Yeah, so a sidecar pattern, I think, is extremely powerful. My first service mesh that I built was in 2000, beginning 2013, and it was with Nginx. So we call it the trampoline, and it was every Docker instance. At the time there was Docker, there was no Kubernetes yet, was basically done with Nginx wrapping the node service, and node would actually only can only call localhost. So in Nginx, what you do, just because it describes how the mesh then kind of like was born, the local instance of Nginx was configured by Ansible, and Ansible would actually inject all the upstreams configuration. So you would not have /* or ~*. You'd have every single route that the service had as internal. And then as external, so that you could bounce it to, was where all the URLs that I could access from that particular service. So the service mesh basically does exactly the same, not with Ansible. They do it with direct communication to the data plane. But that's basically the principle, right? So the trampoline, where your service can only call localhost, can only call your sidecar. The sidecar controls the peer-to-peer communication. I agree. The biggest advantage is probably that you have free metrics, free telemetry. From a security standpoint, you have a central point of organization and configuration of point-to-point communication. But I think when you talk about service-to-service authentication, and so that's where I think it gets super interesting, is that with the sidecar, I can actually do MTLS, right? So I can do X509 between nodes. And that gives us basically a couple of interesting.
Well, so you can always do that, but you can do it without having your original service being just plain text, okay, and have the mesh network setting up the X509 all encrypted system, but without any code change on your on the application end. Now, the reason you people want that is because handling those kind of things on the developer side is actually, it's a lot of pain, okay?
Yeah.
And it's a lot of pain and a lot of work, and also typically not the concern of the application developer, and easy that they can get it wrong. So moving that into the infrastructure is actually not a bad idea.
But what about, I mean, for example, certificate rotation?
So
like you need to rotate, right? Because
yes,
everything needs to be rotated.
yeah, there is stuff to be built, of course.
Yeah, no, but I mean, I'm a big fan that all these kind of like infrastructure components, Node has never been designed to do that. Like that's my standpoint. I don't think I would ever leave Node to do any SSL, to be honest with you. I just don't trust it. It's slow.
It has improved, Okay. Frankly, the problem was not SSL to begin with. Okay. The problem of Node.js was the HTTP parser. The HTTP parser has been made solid. I am confident that the latest and greatest version of the HTTP 1.1 parser and HTTP 2 systems are rock solid. Okay, they don't have any vulnerabilities in there. So that is in 2025. It's good news. Okay, we had quite a lot of vulnerabilities in Node related to the HTTP parser. So I think we got all of those vulns out of the system. Okay, frankly, HTTP 1.1 seems very trivial as a spec. There is a frigging huge load amount of possible vulnerabilities there because the spec is relatively lenient. And however, on top of the spec, there has been a huge patch of the spec and addition to protect against certain things.
But don't you feel that actually kind of like, why should the application, I take a kind of like segue on a different angle, right? Because I'm a big fan of like segregation of control in distributed system, right? And I think that actually that I think Node is a great machine in this case to run logic, business logic,
No, it's great.
right?
It's great.
But it's uncomparable the power that Nginx even or Envoy can actually have on the network level. Right?
So Envoy, I have been unimpressed, to put it on the performance that I've seen. Okay, doesn't look pretty good. Okay, funny part. Envoy used the same HTTP parser of Node, just so that you are aware. Okay,
Yeah, before it was copied from Nginx. So let's be very honest. It was the mod HTTP of Nginx.
Yeah. So it's not.
No, that didn't really invent anything.
No, absolute zero, 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 zero,
That's
zero, zero. There's nothing invention, but I was not
luckily.
impressed. I was not impressed in the sense of I saw, when dealing with a lot of traffic, I saw Envoy consuming a huge load of resources. Okay, way more than I would have expected for that kind of functionality.
But pure Envoy or Envoy in Istio, Envoy in Kuma,
Envoy in Istio.
Yeah, but in Istio there is a problem that Istio, why is a monstrosity? Luckily, we can put it behind us. Istio was designed as the most monolithical system ever probably invented. I generally and provocatively say in front of everyone that whoever was in love with Istio probably was making a huge mistake in understanding technology, because how Istio kind of like was designed was extremely slow and extremely complicated, right? And it was there to fulfill a use case that, generally speaking, I never seen. But if you tried, I'm very biased here. I love Kong. Kuma, that I was lucky enough to be one of the spearhead of the project and as an early believer, had a completely different approach. Like the approach that Kuma had was insanely fast and smart. Well, now for the people listening, Kuma exists under the umbrella of Kong Mesh or part of Connect also. But I think Istio was the major problem there, Theo, because Envoy is very lean. It's actually a C++ thing.
I was thinking the same. I was just seeing it using 500 plus megabyte of RAM for not.
That's Istio. That's all the garbage that Istio is putting in.
Like I was very much not. I was really unimpressed by. Okay, the cost of running those kind of technologies, was very steep.
Yeah.
Compared to compared to all the things that they do. Okay, like you can say they do all this block of things, and then it has a certain level of cost. Okay. But in a lot of companies, a lot of cases, those things were just, I don't know, slapped in. And in a lot of projects that didn't need all this kind of power. And in those cases, probably avoiding it completely would have been like a huge win. But I was really not, I thought, okay, how much memory of things can this consume? Okay. And it was literally, I don't know, 500-600 megabytes of RAM. And we're like, what? Okay. Like this thing shouldn't.
Yeah, it's to be honest with you, I mean, I don't want to kind of like segue too much, because I think it's nice to walk through the different things of like zero network, but let's kind of like be a little bit provocative today. I feel that I love this topic so much. Like,
So instead
I
of
always,
Istio, what would you use?
instead of or lifelong Kuma. Like I would never, I generally would never think of using anything else. Like Linkerd, like the microservice service mesh, to be honest, is a scam, in my opinion. And with all the respect to them, I think the purity of so why I love Kuma. Let me say that, which is not Node, right, guys? It's just like a shitload of Go, because Kuma interpret the concept of homogeneous network, I think, in the best way possible. Like with Kuma, you could actually have an on-prem system working with a cloud system back to an on-prem system, and see them as a single network. Where I think the other one fell short is that they try to be specialized system, right, for microservices, while Kuma only had one principle: network, like pure layer 4, layer 7 network, like OSI pure implementation. Why that's interesting? Why that's nice? Because I can basically use it as a framework. I remember chatting with Marco Palladino, the CTO, and I told him one day with also Reza, the VP of product, and I said, guys, I think it'd be super cool to just implement OPA on top of a service mesh. And believe it or not, the implementation was like extremely fast and simple. Like the team was able to implement together with Stira OPA on top of Kuma in no time, right?
Ooh. Oh.
So, but where I think actually Kuma miserably sucks, right, is that, and I ask you this question, like I turn it around to you, like Theo, you run Node from a lifelong, right?
Yeah, pretty much.
We saw customers, we saw different things together, separately, independently, whatever. You saw Kubernetes. I forced you to enter the world of Kubernetes deeper and deeper and deeper. And I think you realize one problem, that there is an ocean in between running a technology like Node and infrastructure. There is an abyss. There is like a universe. Now the service mesh with the sidecar, what exactly does it add to solve this problem? Like as a developer, right? What exactly does it give you more? Nothing, right?
This
Well,
bottle.
this bottle, right?
This
Why?
bottle. Which
Because
is a very
once,
nice bottle, by the way.
let's shout out to our friends at
24 bottles.
24 bottles.
That they are there. Let's see if the logo shows up. It doesn't.
This is not a sponsor, because we paid a lot of
We
money
paid
for
a lot
this
of money for the limited edition with our old logo here.
old logo. So now it's even more limited. But a service mesh adds a layer, right, that fundamentally is useless to you and just is useful for governance, right? So when I was talking with Marco, I actually told him, and we were in recently having dinner in Vegas. I told him, you are actually not creating more friends. You are creating more governance governance army, which is true, right? I mean, governance is needed in enterprise. But now I'm actually telling you very, very provocatively. Can we do the same exact thing with what? And solve a real problem for people?
So, funny enough, yes. So there.
But don't give the solution. Don't give me the solution. It was a tricky question.
Ah, you
It was
don't
a
do
tricky
this to
question.
me, Luca, because
It was a
you
tricky
asked me a
question.
question and I want to point you to a flurry of npm modules that we released, Apache 2, that can do this. Okay, and you can,
I
you
mean,
know,
they're Apache too, okay, you can tell a little bit, but not all the secret sauce.
so well, so it's a set of things. Okay, so first of all, um, one of the things that we allow with that is to customize the HTTP stack of Node.js, and it's based on top of this library that's part of Node. I contributed there a long time ago, called Undici, which is the next gen HTTP layer. It's also what powers fetch in Node. Now there is this technology called so if you want to do, for example, MTLS with with this, okay, you can, because there is a dispatcher that you can include and use, and it's super easy to add them in Undici, and you just use the dispatcher and everything works, and you don't need to worry about anything. Okay, and that's it.
But my
Essentially.
question is, going back to what we said last time, right? There are a lot of topics about zero network, right? We can fly over, but for example, I mean, you're also familiar to that. Like we talk about MTLS, so we could spend probably an hour talking on how you should actually use Vault to do MTLS provisioning,
Yes,
right?
we should do that. Like, this is another topic. Like, look, we have 15 minutes. We need to go.
So let me say something for Vault and this thing. I really want to invite my friend Kerim from HashiCorp to talk about Vault and MTLS.
Oh,
So,
yes, we should do that.
okay, I will send him a message and I will make sure that he joins us. It would be actually cool when I'm in Amsterdam if we can do it together. That would be like a new twist to our weekly banter.
Ooh.
Never say ever. We could talk about some sort of token-based authentication mechanism in zero trust. So, and we have been there, right? JOT across services, we mentioned last time. But I think what is pretty interesting in thinking about zero trust network and zero trust architecture is the developer experience.
Yes.
Right. I feel, and Theo, correct me if I'm wrong, that zero trust, so service mesh or proxy based, they are some sort of like way to abstract again even more that problem from developers, right? But my question to you, because you taught me a lot about testing, right? You forced me actually to write tests. How in this world can I test my application in a zero trust network locally?
You don't.
So, but how can I say that it will work? What actually sets me between success and failure?
So this is the problem, where usually that's the reason why I think a lot of companies liked solutions like Istio, Envoy, and so on and so forth. Okay.
Kuma, don't forget.
Kuma.
Kong
Okay.
Mesh.
Linkerd, whatever you want to use. Okay. Because you can fundamentally completely split the problem. You always call plain text locally, so that everything is testable, can work correctly. Okay. But then you do the actual you do the actual flow, okay, in So when you deploy in production, the flow of the communication is MTLS supported. Okay.
But also imagine this scenario, right? I'm building service A that depends on service B.
Mm-hmm.
How do I test it locally? Because I deploy and I say it works, and then something fails on the mesh level. Because I cannot control. I
fun.
cannot
It's
control it.
fun. It's fun. It doesn't work because somebody didn't put the thing in a policy. You're screwed. You need to bribe somebody in your company to fix it for you.
Because we mentioned last time, and we should get Emre. So let's. I will drop him a message and get him here because I think
we should get MREF to talk about permission. Absolutely.
Because once again, I think I, as a system, need to know the permission and test against permission. Like, I don't understand why. Imagine that you and I were building something and I say, you're accountable for permission and I'm writing the code or the other way around. You write the code and I control permissions, right?
Yeah.
You tell me that things are working. I tell you, no, they're not working. And then who is actually in fault? We don't know. We need to go down. But what if I would tell you, look, Theo, this is your permission. This is the permission scheme, right? Use it to run your unit test.
Mm-hmm.
Right? You could actually test a failure on your side. What if you get a 403 from service B? How do you behave? Because you basically assume that you're in a trusted network, right? For you, the trust is in the policy, is not in your session, right? The policy needs to be validated against the session needs to be validated against the policy. So my question is, aren't we kind of like didn't we kind of like build a layer with zero trust network that yet create another appliance instead of actually we should have thought first about the overall principle and architecture against the real world. What I'm trying to say, right, in a very kind of like probably complex way is we build a lot of service meshes. We build a lot of like complexity there because it's a new appliance. We create vendor locking and dependency in organizations, right? It's good for the people selling this, right? But at the same time, how did we make developers' life easier and while still granting for security? Because you taught me something. You said security is not a third-party problem. It should be a first-person problem. Right?
100%.
Right? So, when we were kind of like building what and thinking about the application server, to be honest with you, this problem didn't exist at the time of WebLogic.
No,
because
it doesn't.
WebLogic was in charge of that.
Well, it's not just that. It's all the things in that system were running locally. Okay, so when we run inside the same domain, so you didn't have the problem of security because in memory you don't have that problem. Okay, and you think where things were remoted,
correct,
they were remoted, but really they were remoted by the system, so nobody had anything to do with it.
So didn't we try to kind of like do separation of concerns? But then at the end of the day, what we just need to ensure success in zero network is to still have this beautiful monolith to execute.
I think there is space for having multiple services and service-to-service communication.
Sure.
But I think we went way far on down the trap of microservices and lambdas and functions and things like that. Okay.
Yeah.
Compared to the actual requirements of our system.
But because I'm thinking about like how do you avoid, for example, for what's his name? Oh my God, cross-service privilege escalation, right?
Yes.
How do you actually would implement that? I mean, a service mesh is kind of like easy, right? Because it's controlled by the control plane.
Yes.
right? And by the way, we are mixing two things. So mesh is about MTLS, and then you have all the policies. But nowadays, I think is basically we shouldn't actually separate them. They're all the same thing because
They solve the same. So there is MTLS, which is mutual TLS, which means that the client has a certificate, okay, and the server has a certificate. The
exactly
server and the client, okay, talk to each other and encrypt all the communication using those two certificates, and both of them typically are signed by the same central unit, okay.
exactly
Which, of course, then you need to have some sort of revocation list being used somewhere to implement that flow. Otherwise, you are a little bit, I don't know, screwed. Okay, because you need to revocate those certificates anyway
correct.
if you want to. Okay, but overall, it's quite tough because then you have all of those things. So you have point to point essentially. Each
Correct.
client has its own certificate. Each
Correct.
server has its own certificate. Now you need to have you need to coordinate all of this. Okay, so the server can validate because it's signed. Okay, so you can validate all the incoming certificates. Okay, and everything works, but you need to distribute all those certificates around, generate them. It's a lot of cryptographic material. It's a lot of work. Like the management side of this thing is actually quite heavy.
Yeah, and I think there is another problem that is it still involves a lot of human, right, error prone configuration, right?
Yes.
Because it's Luca that says A and B can communicate, right? There is it's not data, right? Like one thing that, for example, I'm extremely impressed that doesn't exist and astonished that doesn't exist. Sorry, is that you said at the beginning it makes open telemetry easier, right? So we
Yeah.
can get visibility. But what about introspection? What about, for example, self-healing configuration? What about like why would I ever think about leaving open a connection between two services on an endpoint that is never hit by A against B? Why would I grant that endpoint? Like one thing is that, and I give you an example, right? And I go back to the time of Nginx. In Nginx, I can say I have different way to set location, where location means a path, right? How many times have you seen really one-on-one path matching in Nginx? Like /foo /asd /foo /star /foo whatever, 1, 2, 3. Like not many times. Usually you see foo /star or
Yes.
right.
Yes.
But
All the time.
then it means that basically I grant everything to foo, right? But
Yes.
what if I have a /foo /asd or whatever ABC, and that endpoint is never called? Why would I leave it open? Isn't it that a recipe for disaster?
100%. Well, it's not a recipe for disaster, minus the fact that it absolutely can. Okay, but it's
My assumption is nobody calls it, nobody tests it.
yes. The
Like,
problem, no, but the problem it goes into another discussion here, Luca. Like, I don't think it matters too much on security, minus the fact that you are authorized to call that endpoint.
yeah,
If you are authorized to call that endpoint, you will call that endpoint. If you have no business in calling that endpoint, you probably should not have the authorization to call that endpoint to begin with.
exactly.
And an attacker will, of course, abuse that. 100%.
But that's for me kind of like also cleanness. I don't know. I'm a little bit OCD with those kind of things and say, why, if you have an endpoint that nobody uses, why? I want an error to be kind of like thrown and raised if somebody uses it because it breaks an assumption. But the other thing that I kind of like I was very, very surprised by using Kuma. But once again, I used Kuma at its inception in early 2018, right? It was like, we're talking about like late 17, beginning 18. There was no AI. But you could still tell me and say, hey, look, I see all these connections going there. There are 20 services that are calling endpoint /foo over 29, over 30 services. Probably you should block these two. I don't see the kind of like system that kind of like help me to maintain and orchestrate that kind of like layer that is in between myself and the network. I don't know. I just because one thing is like I don't see, and this is probably falls into the part of automated scanning, for identity and authorization misconfiguration, right? So when humans kind of like do a mistake, a boo-boo in setting up the network. So I don't know. I'm just like thinking there is still a long path to make a zero trust network a primitive instead of a consequence of our architecture. We were recently at a customer, right?
Yeah.
And do you think a zero trust network was a primitive, an after the fact thought, or, oh yeah, no, you're right, we should do it?
Oh yeah, we are right. We should do it. And we all know that they're not doing it.
But there is no customer actually that honestly thinks about it, right? Because everyone says, oh, I'm using Istio, or I'm using Kuma, or I'm using this, and it's fine, I'm covered, right?
Yeah.
But for example, when we were in the beginning building Platformatic, right, we built a mesh without using a service mesh, right? We built our own.
Yes, we did.
So because we implement the principle of zero trust on a system we were building, right? We didn't take a product and say, oh, I'm covering the requirement of zero trust with this product, right?
Yeah.
And I think that's actually the fundamental difference nowadays in zero trust architecture, right? Is that we set like principles of architecture like microservices as a principle, right? But I think microservices should not be a principle, should be a consequence of a system, not a principle. Well, zero trust should be a principle and not a consequence. You know what I mean, right? I mean, we start the conversation always, and most of the time architects we talk with, oh, we need to build a microservices system, but they never ask themselves why. Does it fit them?
No, never fit them at all, ever.
Like,
I don't know why.
Like we recently were working on this streaming architecture, right?
Yes, fantastic. I hope we can do a case study one day. This is actually pretty nice.
Yeah, but what actually amazed me, and I also told our customers that, okay, you start with CQRS. You start with CQRS, like probably we didn't name it CQRS, but the question is, okay, but why? Like, first describe what you are trying to do, right? I want to have a socket with reconnection, with multiple streams. It has to be safe, secure, isolated, blah, 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 blah.
Yeah.
And they pump a lot of data, right? In kind of like a chunk.
Huge amount.
So, and it's a one-way system for reading, right? Because they don't write.
Yeah, it's a typical system. It's a typical system that is on a specific API for reading.
Right. So you do fall in our case in the bucket of CQRS, right? If you want, like segregation of control over write and read. But at the same time, you shouldn't actually take the white paper or the canonical definition of CQRS, right? And describe it. You should actually adjust the principle. So CQRS is a consequence of what you need. It shouldn't be the guiding principle on building the system, right? Because at the end of the day, if you don't have a right system, but the right system is in the opposite side, we are actually building a different type of CQRS. It's a two-leg system where you have a data lake, basically. So a cold, right, a normalized system that normalizes to a stream to the consumer. So kind of like, yeah, sure, secure S, but is that canonical secure S? Because
No.
a secure S, we are talking about a bank that does write a transaction, read transaction.
Yeah, but most companies like have read the book and then they implement their own secure S system.
I agree, because where is state reconciliation in that particular case? Isn't it state reconciliation a core driving principle of secure S? Because if I segregate read and write, somewhere needs to basically create consistency between these, and so then you go into event sourcing, right? But without going into that direction, it's kind of interesting that we started with the zero trust as we love it, and then we ended with we question if zero trust should be a primitive, a consequence, or I just get it done because somebody tells me to do it. And it's funny that we both agree that as a guiding principle, there is a huge gap in being a principle and being something usable by developers.
Oh, all the time. It's horrible all the time, Luca.
But then why in the cloud world, why in the modern, in 2025, zero trust is not a primitive of the network, but is basically a layer 7 thing, is an application level concern? Right. You talk about protocols, right? And I'm saying, why don't we go one level deeper? That's good, deeper, like lower, I meant.
One good thing about, for example, AWS is that you can essentially set up your VPCs, okay, as essentially some encrypted traffic zone.
Yeah.
Okay. And then between via the peering to other VPCs, system can talk. Okay.
Yeah.
And you can essentially limit in that way via the network encryption and protection and provide that same level of essentially one level down and provide that encryption there in this way.
That has to do with the security groups, though, right?
Yeah, well, the security groups is just blocking the policies. Okay. I think there is some other settings. I don't remember exactly. Okay. Related to having the network traffic fully encrypted between the peers.
The network trafficking.
Let me Google it up.
Oh, you mean to do MTLS
Yes.
Between the system? Well, I mean, AWS has both a service primitive to do that, right? Which is their kind of like interpretation of a service mesh. But in between infrastructure, like what you were trying to say is that because a VPC represents basically a group of resources.
Yes.
Right. But would you use a VPC for each service?
No, absolutely not. It's more coarse grained. Okay.
Correct. Exactly. To go fine grain, I think what you can do, well, you can even assign policies between services, which is kind of like, I think AWS, what it did, and not to oversell them, but they really interpret the security as their primitive. Like with AIM, they have policy as primitive of the network and their services, which is, to be honest, I think that's what I was expecting the generic network to be, the generic world to be in 2025.
Indeed.
GCP has something similar, right? They with their OIDC overlay, and then also Azure has it with Active Directory. Like Active Directory is back, right? Yeah, in Azure is like also they're primitive because clearly that's
fantastic
thing. But yeah, I think I if you don't have anything else, what I would like actually to end is a question to everyone. Do you think zero network should be a primitive, an after the fact, so a consequence, or should be a requirement? tag is three different angles. One should be a primitive, is like basically something that developers get as their foundational piece in their developer runtime.
Mm-hmm.
It's a consequence. It means that somebody else decides for you that you need to use it, and then it's something kind of like that after the fact you implement. Or is a requirement. It means there is something that, like a product that should theoretically overarch that fulfillment of requirement. And then going deeper, why is zero trust not embedded in modern protocols? Any protocol, right? And that opens the conversation to our next possibly chat about Open API, where we start.
Oh, right? That's going to be more and more, way more in my hallway, and really, maybe up my sleeve.
And I think it's going to be cool to kind of like, I would love actually next time to also talk about the controversial conversation about MCP and the Open API world, and a little bit kind of like implementation of these modern integration protocols.
Oh
and
yes,
authentication and
that's
authorization.
super fun. But I don't know why people got so upset about all of that, to be honest. So
I think it's because there is the same concern that I was telling you too. Like, if now we are expanding this mesh of integrations, right?
Yes.
Why don't we have a universal way to define integration policies and identities?
Haha, true.
Right? Why isn't that embedded into the protocol instead of being a consequence, right?
Yeah, true.
That I need to implement, right? So I think we kind of like found a nice talking point, because then I think I would love to go in the same direction with GraphQL.
Yes.
Right, because he's the other kind of like big player in.
Well,
in
the
this
question, there was a tweet from a friend that asked, why GraphQL? Why not GraphQL? Like as the protocol for MCP, okay, for connecting AIs. Why not GraphQL?
Because I think MCP is extremely close to SOAP as a protocol.
But so is GraphQL. So
yeah, but GraphQL, so is GraphQL. You're right, because GraphQL has schemas, is schemaful, clearly. GraphQL is a single post, like SOAP, right? SOAP is a post.
So we are going to spoil. We're going to cover this topic in one of our next sessions. So
yeah, that's actually a very interesting question. Why not GraphQL?
Why not GraphQL? I have an answer. I can answer that question. So I have an answer for all the people watching it.
I think it becomes down to the decoration of the protocol and the communication.
Very close. You're starting to get close to home. But
So,
we'll chat
but yeah,
later.
we will see. Yeah.
We'll see. Bye,
Thanks,
guys.
guys. We
Bye-bye.
appreciate. If you have any question, you know where to find us. We are looking forward to see you next week. Same time, same place, same people. Bye everyone.
Bye-bye.
Ciao, ciao.